Hello students, this is Dr. Maya Dunne. I am giving the overview of chapter 1. You may need to study a little bit more, but I try to give you the overall idea what are we discussing in chapter 1. So chapter 1 has talk about the atoms, um, the subatomic particles including electron, proton, neutron and their charges, elements and the atoms, elements and the periodic table, isotopes and atomic mass. So matter is anything you can see around you. It can be your computer, it can be your book, so anything. So anything that has the mass and occupies space is matter. Mass is the one of the ways how the scientists measure the amount. So always, as a chemist, as scientist, we need to look at an issue in a scientific method. Its scientific method is not biased, it's based on the observations, laws, hypothesis, and then we confirm it using theory or model. Observation is collecting all the, like what you see around us. And then, you try to I would go this way. Okay, give me a minute. So this should be, I'm so glad. So this actually, after observation, you come to the hypothesis. Hypothesis is the, how do you try to explain your observation uh, using experimentation. You do experiments and then it goes to the laws and then the theory or model. So if I'll take a simple example. Think about you go to a friend's home and you started sneezing. So, what is your observation? You visit to a friend's home and you started sneezing, and then you saw a cat. So, these are your observation. So, what is your hypothesis? Before doing experiment, you come to the hypothesis, oh, I'm allergic to cats. That is your hypothesis. Your hypothesis can be true, can be correct, or it can be incorrect. In order to make it correct, you have to do the experimentation. What is the, so you have to plan a simple experiment. You go to your another friend's house with no cat and you see you still sneeze. If you still sneeze, that means you're not allergic to cats. But if you not sneeze, it shows you, okay, I am allergic to cats. So in that way you come up with the experiment. And then law is the concise statement, observe pattern. So that's the, okay, so you know, oh, I'm allergic to cats. And then this is a very simple example. And then you come up to the little bit higher than law, it's a theory and the model. In order to confirm a theory, you need to do so many experiments. And then, so you know that is correct. So that is the scientific method. And then all around us, made out of, like I told you, it's matter. The atom is the smallest quantity of matter that still retain its properties, atoms, and the elements. So this is an atom. And then, sorry, this is an atom and this is an element. Sorry, this is an atom. Element is this. So this is atom. Atom can break down into elements. Element is the substance that cannot be broken down into simpler substances. If you break down the element, it is going to be, it's not that element anymore. Example, oxygen is an element. Oxygen atom is like many elements made of atom, and then the element is the smallest one. If you break down element, oxygen element, there's no more oxygen. So that element is the smallest quantity. So there are several scientists. How do I know these things? Because several scientists did the experiments and they only found out, okay, this is the element is the smallest quantity, and then atom, and if you break down, you cannot break down elements anymore. So the first scientist work on the atom is the Dalton. Dalton devised a theory to explain some of the important observations. So these are the Dalton's observations, Matter is composed of tiny indivisible particles called atoms. So matter, your book, your computer made out of tiny indivisible particles called atoms. All atoms in a given element are identical, and atoms of a one element are different from atom of any other element. So how do you know elements? Elements of the periodic table of the elements. So each atom, oxygen atoms, different from hydrogen atoms. But if you take oxygen atoms, they are all identical. So the atoms, if you break down elements then atom has the smallest particle, that is subatomic particles. Those are electron, proton, neutrons. Electrons are negatively charged, protons are positively charged, and then neutrons are no charge. So if the element is neutral, it has same number of protons and electrons. So you need to know the subatomic particles. Very first scientists work on the atomic structure. How is the structure in atom? Where's the subatomic particles located? For scientist is J.J. Thomson. He found out plum pudding model. The very first structure for atom is this one. But the Rutherford, which is the J.J. Thomson student, didn't want to accept this plum pudding model, and he was continuing his experiments, and finally he did the gold foil experiment. The gold foil experiment is the um, experiment for the nuclear atom, and we still go with the nuclear atom which the Rutherford discovered. This is how the Rutherford did the gold foil experiment. So the Rutherford's gold foil experiment is very important. So this is a gold foil. Think about it. So this is the heating screen, and this is a gold foil. Gold foil, think about aluminum foil, but instead of aluminum, it made out of gold. And then he sent the alpha particles through the gold foil. He noticed many particles go through. Okay, many particles go through, but 1 in a 12 million particle deflects. Like all the particles everywhere go. So that shows that the atoms, why it's coming back, because most of the space of the atom is empty. So because of that, the particles can go through. But why there's a 1 in the 12 million coming back, bounces back, because there is some mass, right? It's dense. It's dense because it has the mass. Atom's mass constricted to a small place. And then he came up with this model for the atom. So we say, okay, this is the nucleus. Nucleus condense the mass, so that's what it reflects. So this is the structure of atom. This is the nucleus. Nucleus contain protons and neutrons and electrons around the nucleus. So and then this is the example. They ask, can you identify the neutral atom? How do you identify the neutral atom? Look at the first one. So here you see that in order to be neutral, it has same number of protons and electrons. If you have same number of protons and electrons, it is neutral because proton positively charged, electrons negatively charged, so it's a neutral. So it's neutrons, it's 10 and 10, so it's neutral, and then this is the neutral charge. So so then so the A and C are the neutral atoms. Okay, so that's the end of that section, and I'm going to the periodic table. All the elements that you can think about in Earth is listed in the periodic table. This periodic table is very important. In this level, I want you to know the element name and the symbol, chemical symbols. It's important. I can recommend you take a printout of the periodic table, and then try to look at it, try to be familiar with the periodic table. You can post on the study table so you know, okay, this is the periodic table, and I'll explain you this one. You see the periodic table is color coded. Green color, all the green color shows metals, blue color non-metals, yellow color metalloids. I know it's interesting. Many metals. There are so many metals on Earth. So these all metals, and these are the lanthanides and actinides, still metals. Very few non-metals. Carbon, nitrogen, oxygen. And then these are non-metals. What are these? These are called metalloids. They have the metal characteristics, non-metal characteristics. We call these are non-metalloids. And then the periodic table, how we arrange the elements according to the atomic number. Atomic number is important. Well, the next one's the same thing. Atomic number is number of protons in an element. Atomic number of protons in an element is the atomic number. The elements arranged in the periodic table according to the increasing atomic number. Atomic number is unique to each and every element. If I said, okay, what is the element with the atomic number 16? You go here, this is the 6. There's no other element with the atomic number 16, so it's sulfur. So that is, and then the periodic table, the vertical lines call groups or families because they share, each group or family shares some similar features. And then the horizontal lines we call periods. If I ask you, find an element which is in period 1, it can be hydrogen or helium. Period 2, lithium, beryllium, like these. This is period 2. Period 3 goes like that. So this is the periodic table of elements. And then if you think about group 1, you call alkali metals. Group 2, alkaline earth metals. Group 8, this is like transition metals. Group 8 we call noble gases, inert gases. Group 7, fluorine, chlorine, bromine, iodide, it is halogens, and then the chalcogens. So that is about the periodic table, and then it's important you know the also the calcium element is C, A uppercase C, and A atomic number, it's 20, I think, yeah, calcium. So you go here, atomic number is 20. You can have the periodic table in the exam. I mean, any type. So then the copper, this is copper, and then atomic number, and 13. What is element with atomic number 13? Mm. So you go there, aluminum, Al, aluminum. Okay, so that is how you do this one, and then it's important, you know, all the, okay, N is nitrogen, silicon, calcium, chlorine, and arsenic. Okay, and then okay, then I'm going to stop from here and go to the part 2.